Hello, and welcome to Backer Breaks It Down. In this episode, we're looking at special right triangles with a focus on the 30, 60, 90 triangle. Now, previously we investigated a 30, 60, 90 triangle. I gave you an equilateral triangle, okay? And I told you the length of a side of the equilateral triangle, okay? This side is representing the hypotenuse of a right triangle, okay? I told you that the shorter leg is half the side length. And then I asked you to use the Pythagorean theorem to find the height of the equilateral triangle, which is the long leg of that right triangle. Okay, so like we already knew if the hypotenuse is 2, the short side was half of that because I told you that much. The Pythagorean theorem told us that the height is the square root of 3. So if the side is 4, the short leg is 2, and the height is 2 root 3. If the hypotenuse is 6, the short leg is 3, and the height is 3 root 3. So what we discovered is if the hypotenuse is x, the short leg is half times x, and then the long leg is 1/2 x times the square root of 3. Okay, now this can be like kind of funky, okay, with all those fractions. I know how we feel about fractions. But essentially what we discovered is the 30, 60, 90 triangle theorem. Now they are saying x is representing the short leg in this triangle. So if x is the short leg, then the hypotenuse is represented by 2 times x. And then the longer leg is represented by x times the square root of 3. And that's like a little bit nicer because, well, we don't really like working with fractions now, do we? But basically, if you know the short leg in a 30, 60, 90 triangle, it's really easy to find the hypotenuse and the long leg, okay? If you're not given the short leg, I would find that first. So let's organize our findings in a flow diagram, okay? So the short leg, that's the best one to know. Because if I know the short leg of my 30, 60, 90 triangle, and by the way, the shorter leg is opposite the 30-degree angle, okay? But if I know the shorter leg, I can simply multiply by 2 to get the hypotenuse. And if I know the shorter leg, I can multiply by the square root of 3 to get the longer leg. Okay, if I don't know the short leg, I should really try and find it first. So if I know the hypotenuse, I can simply divide by 2 to get the shorter leg. If I know the longer leg, I can divide by the square root of 3 to get the shorter leg. Okay, so let's actually apply this theorem, okay, in a few examples. So in problem number 4, this is the triangle we're working with. Notice we are given the hypotenuse. Okay, so I'm given the hypotenuse, so I can divide by the square root of 2 to get the shorter leg. Okay, the shorter leg being x. So I'm taking the hypotenuse, 24, I'm dividing by 2, the shorter leg here is 12. Once I know the length of the shorter leg, I can multiply it by the square root of 3 to get the longer leg. So the longer leg is y. I know the shorter leg is 12. So 12 times the square root of 3 is simply 12 root 3. So that one was pretty easy, I think. So let's try another one, okay? So really, I'm trying to stump you here. Kidding. So number 5, we are given the same information. We are given the hypotenuse. So since I'm given the hypotenuse, I can divide by 2 to get the shorter leg being x here. So if I take 18 root 3 and I divide this by 2, this one is not that hard to do because when I'm dividing with radicals, I can divide insides with insides and I can divide outsides with outsides, and that's all I can do here. 18 divided by 2 is 9. So I'm looking at 9 root 3 for my short leg, which is x, okay? So now that I know my shorter leg, I can multiply this by the square root of 3 to get the longer leg, okay? So that would be y. So I'm taking 9 root 3 times the square root of 3, okay? So we multiply insides with insides, outsides with outsides. So I can go square root of 3 times square root of 3, which we all know is the square root of 9, which is just 3. So really we're multiplying 9 times 3 here, and we're getting 27. And that's the length of our longer leg. Okay, so this one really wasn't that bad. Bottom line is, if you don't know the shorter leg, find it first. Okay, so let's take a look at one more of these. Okay, so in problem number 6 here, I am given a leg of 9. Notice, sorry about that. Notice that it's opposite the 60-degree angle, which makes it the long leg. Okay, so I should find the shorter leg first, okay? So I have the longer leg. To find the shorter leg, I need to divide by the square root of 3, okay? So I need to take 9 and divide it by the square root of 3. Now, 9 is an outsider, 3 is an insider. They cannot be divided, okay? I cannot leave the square root of 3 on the bottom. So I need to multiply the top and the bottom by the square root of 3. So this is called rationalizing the denominator. And so when I do that, on top I have 9 root 3. And on the bottom, I simply have 3. And then I'm looking at that outside fraction here, and I can totally simplify that. So I should definitely do so. It will give me 3 root 3. Okay. And that's the length of the shorter leg in my right triangle. Once I know the shorter leg, it's really easy to find the hypotenuse. I simply have to multiply by 2. Okay, so I'm going to take 3 root 3 times 2. We can multiply the outsiders together. 3 times 2 is 6, and then 3 stays on the inside. Okay, so the hypotenuse is 6 root 3. And so that's how we can find missing side lengths in 30, 60, 90 triangles. Definitely, if you know the short leg, that makes it really easy to do because the longer leg is the shorter leg times the square root of 3, and the hypotenuse is the shorter leg times 2. And if you aren't given the shorter leg to start off with, find it first, okay? And that's how Bakker breaks it down.